Hello everyone, this is part 2 of our differential equation. We're gonna be continuing our homogeneous linear higher order differential equation with constant coefficients. Let's proceed to y double prime minus 6y plus 9y. Okay, same method. We're gonna convert them to differential operator. D square y minus 6 dy plus 9y is equal to 0. Okay, separate y, d square minus 6d plus 9 is equal to 0. Find the, or separate the polynomial, d square minus 6d plus 9. Let m be the roots of the equation. Okay, equation. Okay, so I'm gonna write down the distinct roots here because I have not write the formula for the distinct roots. Okay, so basically if we have like m1 m2 not equal to m2, we just write them c2 e raised to m2 x, right? It's not equal to m3 plus c3 e raised to m3 x, right? That's distinct root. Okay, we're gonna be solving for number 3. I'm just gonna go back again. Let m be the roots of the equation. We will now have our polynomial m squared minus 6m plus 9 is equal to 0. Okay, this is our polynomial. And the root will be our solution. So if we factor this out, this will become m minus 3, m minus 3. Now, this number is a good example of repeating roots. Okay, case number 2, repeating roots. Okay, repeating roots. Okay, if we have a repeating root, let's say we have 3 roots of 3. So let's say m1 is equal to m2. Our answer will become c1 e raised to mx. The second term or the repeated term will have an x now on the coefficient or the constant, x e raised to mx. Okay, now in this case, since there's 2 3, we now write c1 e raised to 3x for the first 3 root, okay, the root 3, this one. For the second term, c2x e raised to 3x. Okay, sir, what if there's like 3 term? What if, example, third term? Then our third term will become c3x squared e raised to 3x. Fourth term, if ever there's a fourth term, c4x cubed e raised to 3x. What if there's like a fifth let's say fifth root, 4, because it's a new number, it's a new root, c5 e raised to 4x. There's no x cubed or x to the fourth because it's first of its kind. Right? It's first of its kind, so it's okay. Okay, it's okay. Okay, but if there's another 4 there, so the second 4 will now have an x e to the 4x. Okay, I hope you get what I'm saying, but okay, for each time a number is repeated, you get an x. For the first time, x. For the second time, x squared. For the third time, x cubed. For the fourth time, x to the fourth. For the fifth time, x to the fifth. For the sixth time, okay, and so on. Okay, that's case number 2. Okay, let's solve again. Let's do another one. Ooh, this is our largest degree yet, or largest order. Okay, fourth example, right? Let's convert this to differential operator again. Okay, I hope you guys are like knowing how to solve, right? It's been 4 times, and basically we just convert them to differential operator. dy plus 36y is equal to 0. Okay, move y, 4d to the fourth minus 4d cubed minus 23d squared plus 12d plus 36. I just remove the y. Okay, find the function of d. 4d to the fourth minus 4d cubed minus 23d squared plus 12d plus 36 is equal to, that's the function. Let m be the roots. The roots of the equation. Okay. So, I'm gonna go, because this is the fourth, because this is like fourth order, I'm gonna go and make it easier for me for now. It's good for once in a while, make it easier for you. We're gonna use a calculator, okay? We're gonna use a calculator. Let's hope that the calculator can have what we call fourth degree. No, there's no fourth degree. Okay. We're gonna use Japi Solved. There's no fourth degree on the calculator. So let's use Japi Solved. X to the fourth minus 4 x cubed minus 23 x squared plus 12x plus 36 is equal to 0. Japi Solved. What do we have? Negative 1.5. Ooh, I want to get a whole number. Let's say positive 1,000. Oh, we got 2. Okay, got 2. I want to get a whole number. Sorry, I want to get a whole number. Okay, so let's say we have a root of positive 2. Just to take out the trial and error part. Okay, it's much easier if you have a calculator, but if not, you have to do the trial and error. And you don't want a long video, right? Okay, you don't want a long video, right? So 4 minus 23 plus 12 plus 36. Okay, so write down 4 multiplied to 2, 8, 4 multiplied to 2, 8, negative 15 multiplied to 2, negative 30, negative 18 multiplied to 2, negative 36, 0. Now, we have now m minus 2, okay, 4m cubed plus 4m squared minus 15m minus 18 is equal to 0. We have now a quadratic equation. Okay, so we have now a cubic equation. We can do mode equation for 4. So we just put 4, negative 15, negative 18, or our calculator. Basically, this will become a is equal to 4, b is equal to 4, c is equal to negative 15, and d is equal to negative 18 on mode equation 4. Oh, sorry. Our roots will become 2, negative 3 half. Okay, that's a cool case. Okay, so take note. This is a third degree term. Okay, and why did the calculator give us 2 terms only? The calculator said our cubic equation will have roots of 2 and 3 half, right? But there's only 2 terms. For our third degree or cubic, negative 3 half, there should be 3 roots. Okay, there should be 3 roots. If we have to the fourth degree or fourth order polynomial, we need to have 4 binomials, or we need to have 4 roots. But the calculator only gave 2. So that's one of the flaw of calculators. Okay, they will not give you what we call case 2, repeated roots. Okay, repeated or repeating. Calculators will not give you the repeating root. Take note, we have now 4m cubed plus 4m squared minus 15m minus 18. And the calculator said 2 of the roots is 2 and negative 3 half. Okay. So now, let me take another, let's divide our cubic polynomial again with 2. because it said that one of the roots is 2, right? 2, 4, 4, negative 15, negative 18. Put down 4, multiply to, I just like scratch it off. Multiply to 4, 8, 12, multiply to 12, 24, 24, that's negative, positive 9, multiply to 2, positive 18, 0. Okay? So, m minus 2, then that will become 4m squared plus 12m plus 9. Okay? And this is now factorable. Let me just join the m minus 2 squared. This is now factorable into 2m plus 3. Okay? Squared. It's a perfect trinomial. Okay? Okay? For our case number 2, our roots is 2 twice. Okay? The other one is 3/2, negative 3/2 twice. Okay? Okay, and that's one of the flaw of the calculator. And that's why I put this example for you guys. So, yes, I may be using the calculator, but you need to have the skills to solve it also, okay? Synthetic division is the key. Okay, we always need to solve it manually, okay? It's not about the calculator, students. It's about the user, right? It's not about the sword. It's the one who hold it, right? The samurai. Okay, anyways. So, we have repeating roots. Our general solution now is C1 e raised to 2x for the first root. Then, for the second root 2, C2 e raised to 2x with the x on the C2 plus C3 e raised to negative 3/2 x. Okay. For the C4 x e raised to negative 3/2 x. Okay. That is now our general solution. Okay. And we can take it further in simplifying. Okay. We can have e to the 2x C1 plus C1 plus C2x. Then e raised to negative 3/2 x C3 plus C4x. Okay, that is now our general solution. Okay, and that is case number 2. Okay, so I'm gonna end the video for now. We're gonna proceed to part 3. Okay, and I hope you guys learn about the limits of a calculator and using it to make it easier to lessen the trial and error. But again, we need to learn synthetic division. And probably if you don't know how to factor this out, we can just use quadratic equation. A is 4, B is 12, C is 9. Quadratic equation, negative 12 plus or minus, or I'm just gonna write the formula here, negative b plus or minus square root of b squared minus 4ac over 2a. So negative 12 plus or minus 12 squared, so 144 minus 4a, 4 which is 4 times 9 over 2 times 4. Okay, so that's negative 12 plus or minus 144. 4 times 4 is 16. 16 times 9 is negative, actually that's 44. I think that's 144. Okay, and 2 times 4 is 8. Okay, 2 times 4 is 8. So the roots will become m1 is equal to negative 12 over 8 plus square root of 0 divided by 8. Square root of 0 is 0, right? And m2 is negative 12 over 8 minus square root of 0 over 8. And again, that's 0. Okay, so we have two roots of 3/2, negative 3/2. Okay. Okay, I said I'm gonna end the video, but yeah, okay, that's quadratic equation. I hope you guys learned, and yeah, let's proceed to part 3.